Welcome to the Day of Datomic training videos. In this first video, Stu Holloway will introduce Datomic as well as the design philosophy and architectural principles behind Datomic. Stu will also demonstrate how to get Datomic installed and up and running, and how to interact with it both via the Datomic console and the REST API.
Everybody, and welcome to the Day of Datomic. It's November 2014, and we are here in Washington, D.C., the day before ClosureConj. My name is Stuart Holloway. You can reach me at Stuart Holloway on Twitter or at Stuart Holloway pretty much any other social media. And I work at Cognitect. And here's the plan for the day. We're basically going to do 6 things. We're going to start by talking about, what is Datomic at the broadest overview level? Why are you here? Hopefully you have ideas why you're here, but I'm full of opinions, so if you're not sure why you're here, I'm happy to suggest possible reasons that you might be here. Then we're going to talk about Datomic's information model. So Datomic's a database. Databases are about information. And the information model of a database is something that is an architectural decision. And I like to use the word architectural decision to talk about things that are difficult to undo later. Right? You choose to build something on the .NET stack. That's an architectural decision. You can't sort of decide tomorrow, I wish it was running in PHP, and press a button and be running in PHP. What the information model of your database is a very big architectural decision. So it's the right place to start. Then we're going to talk about Datomic's transaction model. So how does data get written into the database, and what sorts of integrity guarantees does that data have? And the short answer is that we are righteous, old school, ACID database. Right? That's how we roll. There are reasons not to do that. It's not the right thing for every possible use case in the world. It's only the right thing for about 99.4% of the use cases in the world. So it's a good place to start when thinking about data. Then we're going to talk about Datomic's query model. So you've succeeded in planning an information model for something you want to keep track of. You've succeeded in putting it into the database. How do you get it back out? Then we're going to talk about Datomic's time model. And this is an area where perhaps Datomic is more immediately distinctive from other databases than other areas. And a short way to put this is, why isn't your database more like source control? And why isn't source control more like your database? Now, with a source control system, you can go up to your source control and say, what does my world look like today? Well, there you go. What did my world look like yesterday? Oh, well, there you go. What did it look like 6 months ago? Oh, there you go. What is the difference between 6 months ago and 2 months ago? Because we know we introduced a bug somewhere in there. We know it wasn't there on the release we made 6 months ago. We know it is there on the release we made 2 months ago. So we want to bisect our way through history and find the problem. This all sounds like a really good idea, and it's a little baffling why most databases don't work this way. Datomic does work this way. So we're going to talk about how Datomic keeps track of information over time and gives you the ability to travel backwards and in some cases even forwards in time. Finally, we're going to talk about Datomic's operational model. So what is it like to put Datomic into production, and what characteristics does it have there? And the short story about this is that Datomic decomposes the traditional notion of a database into multiple smaller pieces. And whenever you do that, you gain flexibility, you gain opportunities. You gain the ability to say, I want to horizontally scale this aspect of my database by putting it on a fleet of machines, and I want to isolate it from this other aspect of my database. This is particularly well suited for cloud operation. It's also particularly well suited for what I'll call agile operation. And here, by agile, I mean making different choices over time of the shape of your deployment, without actually having to change your system. I mean, there are some kinds of changes that would be like, oh, I want to deploy to do a different job, right? I've collected a bunch of transactional data. Now I want to do analytics on that same data. Well, I want a different information model and a different operation model. That's a bummer of a place to be. Has anybody worked in that kind of world where you have to do some kind of ETL job to get data out of one system, to put it into another system, to ask a different kind of question? So it's an objective of Datomic's to not put you in that situation unnecessarily or casually. I'm not saying that there is any one-size-fits-all best way to shape data for every possible use case. But if we're mindful of that, we have a better chance of being able to deal with different kinds of requirements over time. So that's the plan for the day. We are being filmed, And so, just ignore the bright lights and the people standing all around you and so forth. We will take breaks. Feel free to stop me at any time and ask questions. We'll take a substantial break for lunch. And there's drink and bathrooms outside. If you have any kinds of logistical questions like that, feel free to ask those as well. Just stop me. We can edit that out of the video, so it's fine for us to have kind of a locally significant conversation about the room being hot or cold or whatever. Any questions before we begin? All right, let's start then. What is Datomic? Datomic is a complete rethink of databases. Datomic's design began at about the same time that the design of Clojure began. So, and those of you who are sticking around for Conj, the t-shirt this year is actually a timeline of Clojure's history. So you can go back and actually see, 8 or 9 years ago, the first milestones. I guess 2006, some of the first milestones there. But what happened was Rich Hickey, the designer of Clojure, gave himself a 3-year unpaid sabbatical. So he had worked as a consultant in IT, doing the kind of stuff that we do. And I'm just trying to imagine the conversation that he had with his family, right? Where he goes and this is what the conversation must have been like, right? Because the conversation was something along the lines of, I have some interesting ideas about tools that would be useful for developers, and I'd like to go flesh them out for several years. We won't have income from me during this time. And what happened during that time was that he created the Clojure programming language, and he did the initial design work for the Datomic database. And then in 2009 and 2010, we started talking about turning that database into a real thing, which it has now become. As with Clojure, Datomic represents a ground-up consideration of what it means to be a database. So the goal was certainly no cows are sacred here. Right? Anything that we traditionally think about how databases work doesn't necessarily have to be true. And there are a set of characteristics that we ended up coming up with that we think are particularly important. One of them is agility. One of the biggest problems that traditional relational databases have is that they're good at some things and not good at others. And because they're the way everybody worked up until, say, 5 years ago, then if they were a good fit for your problem, you got to use them. And if they were a bad fit for your problem, guess what? You got to use them. So Datomic is agile. And by this, I mean it supports really late binding of your choices. Being able to come back and say, I want to ask different questions about my data than I thought I did when I put the data in, and not have to sort of change the way you work. Datomic is robust. And this kind of robustness I'm talking about has all to do with immutable data. So we'll talk more about that. Datomic is powerful. What does it mean for a database to be powerful? I think the best way to think about this, if you haven't spent a lot of time thinking about designing your own database, is what makes a database different from the file system. Right? Your file system stores stuff. So could I argue that your file system is a database? Would you have a very good experience if you wrote your web application and everything worked by writing stuff into files here and there? There are problems with that. And so the power that we're talking about here comes from two things, really. It comes from organization. So it's an organizational model for how things are stored. And then it's a model for how to get things back out. And the important characteristic of that model is that it be declarative. Right? So being able to say what you want, not how to go get it. And that's the difference between your file system, where you go up and go say, navigate here, navigate there, give me a list of what's there, and a database where you say, I want this stuff. You go figure out how to get it. You know how the information is organized. Go get it for me. Datomic is time aware. This also stems partially from its roots in functional and immutable style of programming. And it was designed from the ground up to be deployed on the cloud. The cloud is the future. AWS just had the reInvent conference this year's instantiation of it last week, and it is stunning how quickly this transition is being made. And our children are going to think about sort of isolated computing capability that you manage yourself, sort of the way we think about people who live off the grid and don't get their own power. Of course, in fairness, that may be a trend that flips back in the other direction with power. But this is where the world is going. And it turns out that a system that's architected well to be broken into small pieces and automatically scaled for the cloud, you get operational benefits if you're running it yourself. The other assumption leads you to all kind of trouble. Right? If you make a presumption that you own a big, powerful, dedicated thing and that all the pieces are co-located in that thing, then you're going to make a ball of mud that's difficult to take apart later. So let's break into each of these things in a little bit more detail. What makes Datomic agile? Datomic has what's called a universal schema. A Datomic database is nothing more than a set of 5 tuples. And those 5 tuples are entity, what am I talking about, who am I talking about, attribute, what attribute of that thing am I talking about, value, what is the value of that attribute, transaction, what transaction made me aware that that value was that value, and then is that thing being added to the system or being removed from the system. And the thing about this 5-tuple scheme is that it has that this porridge is just right quality. Right? Because it turns out that if you store less information, right, if you pick something smaller than a 5-tuple, like let's say a pair, key value, right? If you made a database that its whole storyline was about key value doesn't tell you enough to actually have an information model. I can say runs fast, right? Key is runs, value is fast. Do you actually know anything? Not much, right? There has to be implicit knowledge somewhere else. There has to be implicit knowledge that these key values are about Stu, right? Stu runs fast. In that case, actually, that would be an incorrect recording, but that's a separate issue. On the other hand, if you store something bigger, if you store a bigger shape than a 5-tuple, so like a relational database where you can say, you know what, I'm going to make, well, how big are the tuples in a relational database? Exactly. It's a good, Gary gives a good shrug there, right? They're arbitrary. And you can tell that that's a problem the minute that you have a column you want to make null. You can tell that it's too big, right? If there's ever a piece of information in your system that's like, yes, this would fit in this table, except these parts are not present. That's too big. And we'll talk more about the power of this later. But what falls out of this is that it's incredibly easy to model things in Datomic. If anybody has ever done entity relation diagram type stuff and designing schemas, the schema that you design translates directly into Datomic without adaptation. Whereas with most other storage shapes, you then have to do some gyrations about, oh, I'm going to have foreign keys and join tables and all those sorts of things that fall out of that. The second thing that Datomic is robust. And this really comes from discontinuing an idea from the 1970s, which was not a great idea. And that idea is update in place data structures. So in the 1970s, memory was expensive, storage was expensive, and it made sense to do a really crazy thing. To say, you know what, we're going to have a data structure that represents a piece of information. And then to represent new information, we're going to clobber the old information and overwrite it with the new information. Then, from the 1970s until now, memory got 1,000,000 times more capacious. I'll say that again, at least 1,000,000 times. You can go back and look at, certainly in my case, the laptop that I have now has 1,000,000 times more RAM on it than the first computer that I owned. It turns out that somewhere between then and now, somewhere between that capacity and 1,000,000 times more, it stopped making sense to forget stuff. Right? You still might choose to forget things because you don't care anymore, but you don't want to forget things by accident. Right? I have a system that's entirely designed that it automatically clobbers old data whenever it puts in new data. And every operational aspect of dealing with this stinks, right? I can't share something with you. If I want to share something with you, it's like, well, what if somebody else is changing it while I'm trying to share it? Right? Because we know that just across the board, data can get clobbered at any time by anybody. How do I share it with you? Oh, we must have to create some sort of defensive boundary. I'm going to put you in an embrace and give you a hug, and we're going to share data together. We're going to be protected from other people. But that's hard to make work. It's hard to distribute those things, right? If I'm distributing shared data, there has to be coordination. Because it might be changing. So I distributed it to you, and then 5 minutes later it changed. Now when you start talking about things like cache coherency, right? Well, cache coherency comes from things being able to change. If things can't change, what happens to cache coherency? Cache is always coherent, right? It either knows something or it doesn't, but you're fine. Likewise, concurrent access and access patterns are totally dictated by the fact that things could change on you. So if I know something could change, I have to get the complete answer to my question in one interaction with another system. Because otherwise, if I ask half of my question, and then I scratch my head and think about the rest of the question I want to ask, and then I go back to ask the other half of the question, what could have happened? Change. Right? Change is really bad when it happens by accident and it's not really part of something we're trying to model. And this 1970s decision really messes us up. And almost everything works this way. Right? The collection classes in the dominant programming paradigms, Java and .NET, are update in place. Relational databases are update in place, typically. NoSQL databases are update in place. So for all their newfangledness, they don't really address this particular issue. On the other hand, Datomic and languages like Clojure and F# use what are called persistent data structures. Persistent data structures remember past versions of themselves and never change. So I have a piece of information at some point in time. I accumulate more information later. And then I accumulate more. And I'm going to call this a sort of an accumulate-only style of work. And you're all used to this because you use source control. Right? Source control works this way. It's accumulate only. There's not a moment 6 months from now where source control goes, oh crap, I'm going to start forgetting stuff from 3 years ago. Or even worse, there's not a moment 6 months from now where source control goes, I'm going to forget everything except what's true right now. So we can talk about technical details about this, but you already know how it works. Especially if you use something like Git or Mercurial, where this works extremely well. So the next idea is wanting to have power. And Datomic really gets power from two different things. Datomic indexes data in a bunch of different directions. It indexes data in a row shape. Right? So something that's compatible with the kinds of things that would be efficient in a relational database. It indexes data to support column-shaped things. So instead of saying, tell me everything about Fred, it's tell me everybody's salary. Right? So it's the attribute that you're looking at, not the entity that you're looking at. Datomic's indexes support navigation. So they support things that you would traditionally do with a graph database. And because you have all these indexes pointing in these different directions, you would never think about doing document storage in Datomic. Right? Document storage is essentially punting on having any power. Because what happens when you store things as documents? Who has to then go crack them open and get stuff out of them? Your program does. Right? The database doesn't have any power over them, right, when you store things as documents. So Datomic, by indexing things in multiple different ways and having the universal schema, provides you all of these. And it provides a logic-based declarative language for getting things out, Datomic's Datalog. So Datalog is a sibling of the relational algebra, which underpins SQL. So this is something that has an academic pedigree and has been under active development in various communities since the 70s. It also supports a declarative model for navigational access. So saying, given that I have a musician, give me that musician's songs, collaborators, labels, right? And doing that kind of navigation. Right? You can write that kind of navigation as a logic query, but sometimes when it's navigational, it's more straightforward to just say, I want to navigate. Right? I'm here, go there, go there, go there. So it supports that with what's called the pull API. Datomic is time aware. And by this, I mean that every fact in the system knows about its time. Remember what we said a Datomic fact was. It's a 5-tuple. Entity, attribute, value, transaction, and then add or retract. That transaction attribute is a total ordering of time in the system. Right? This happened, and then this happened, and then this happened. And that transaction attribute is associated with wall clock time because the total ordering may not excite you very much. If I tell you it happened at point in time t 7,400, you might go, yeah, well, what does that mean to me? Right? But I can also say point in time t 7,400 is associated with wall clock time April 1st, 2012. And then you're like, okay, I get that. Because everything is stored that way, you can take what we're going to call the default view of a database. The default view of a database filters out everything that's not currently true. Right? So something that used to be true but it's no longer true. So that looks like a traditional database. Right? Tell me what's true right now. But you can also do an as-of filter. As-of says, take me back in time. And it works by filtering out stuff that happened more recently. You can do a sense view of the database, which says, filter out the old stuff and show me only the new stuff. You can do a with view of the database. The with view of the database is quite interesting. This says, take a database and then speculatively add this data to it, but don't actually transact that data. So actually, when we were creating this feature, I lobbied, and I will continue to lobby by saying it in public like this. I wanted this to be called as if. Right? What would the database be if this additional information was added? The history view of the database gives you a timeless view of all history. So you can say, tell me everything that happened, things that used to be true, things that are true now, things that were true in the middle, whatever. And then also there's this notion of a transaction report, which says every time you make a transaction, the return value of a transaction is not, true, the data got in it, or false, it didn't. The return value of a transaction is a map that has the before state of the database, the after state of the database, and the delta in it. So every operation in the system can tell you, what did I do this to, what did I end up with, and what's the delta? Question?
I was just wondering, why is it called with and not as if what were the arguments for with?
I'm not going to support Rich's arguments for with. He's here at the conference. You can walk up to him and say, it really should have been called as if. Stu is really good at naming. You should listen to him more often. I think you should definitely do that. And the last point I want to make about what is Datomic is that Datomic decomposes the traditional database. The traditional relational database does a lot of things, right? It accepts transactions. It performs indexing. It performs queries. Right? All the different jobs of being a database get done in one process. And eventually what you find is that that's not great because that forces you to make 6 choices at once when you buy your database. Right? I have to take this and this and this and this and this. What Datomic does is it makes 3 important separations. Query happens in an independent process from everything else. Because query happens in an independent process from anything else, you can have as many of them as you want. So you notice that there's more than one blue circle here. Transactions happen in their own independent process, and that's called the transactor. You see there are 2 of them here. Typically, a Datomic system will have one transactor running, which is doing all the writes for the system, and another one on standby in case that guy gets sick and falls over. And then storage, so here the I/O capability, is modeled as a service. And what this means is that you can pick your information model. I want Datomic's information model. I want time and history and the agility that we just talked about. And then you can make a separate decision about where it gets stored. This turns out to have a huge political, practical element to it because there are companies who have a policy like we can put our data anywhere as long as anywhere is named Oracle, right? Or we can put our data anywhere as long as anywhere is named Cassandra. And Datomic lets you say, oh yeah, I built a system, but you're ready to go, right? We're going to store the data in Oracle. We're going to store the data in Cassandra, wherever you want to put it. So that's what Datomic is. It's a database that is agile, has a flexible information model. It's robust. It depends on immutable data structures. It gives you a model for time, and it operationally deconstructs the way that we traditionally deploy databases. That's the end of the first module. I'm going to give you instructions for the lab in just a second, but I'll stop now and take questions. This is a good time to do a lot of questions because if you understand the ideas, the rest of this is just going to be, an easy swim. So any questions right now? Yes?
So it's the model is kind of like a repository. And just to kind of dig deeper, is there anything like rebasing in the sense that history can change?
So the question was, is there anything like rebasing? Could history change? And there are several important things to know there, and we'll talk about this more later. But short sketch, Datomic is an ACID system. So there's nothing like forking and branching and having alternate histories. There's one history. It's designed for system of record recording of things. So in that sense, no. There's a separate sense where you get a privacy notice from somebody saying, remove my data from the system. And Datomic has a dedicated feature for this called excision that says, we have to remove this person's data. We have to literally go back in time and pretend like something never happened. That's actually an accidental behavior of traditional databases, right? They do that all the time. 99% of the time, it's not what you want. You don't want to pretend like stuff never happened. But every once in a while, you are actually obligated to pretend like stuff never happened. And so Datomic has a special feature called excision that you should use for that and for no other purpose, right? So one of the big anti-patterns in Datomic use is people start using it. And you always bring the baggage of your own metaphors to a new thing that you're learning. And people are like, I want to get rid of something. I'll excise it. Don't do that. right? Excising is like having a cancer removed from your head, right? That's not what you want to do. Forgetting something is changing your mind and having a memory of what you did, and there are much easier ways to do that. Other questions? Yes?
So it's an acid system, and I've looked at it a little bit, but do you have much flexibility with the consistency aspect? Because a lot of times with databases, that's one of the biggest problems is it constantly tries to maintain consistency, especially like an SQL database is multi-threaded and it just throttles all your CPUs trying to maintain consistency.
So the question is, let me paraphrase a little bit. Acid good, but performance problems and configuration knobs wanted. Datomic's answer to this question is very simple. And the answer is Datomic has only one writer thread, period. It's not serializable, it's serialized. And so so if you're worried about all the headaches of configuration knobs and people turning down consistency and breaking their systems, we're worried about that too. On the other side, you're worried about getting enough performance. Well, this deconstruction of the database really matters, because one of the things that happens in a traditional database is there are a lot of different jobs competing for the power. In Datomic, the box that's doing writing, that's what it does. It's like the Terminator of writes. That's what it does. That's all it does. And so you can get the throughput that you need from that one writer thread. And there's some interesting research about this where people took traditional databases and turned them into single writer systems and found out that they were faster. And so we're leveraging that insight. It is definitely the case that there are write scale jobs for which this is unsuited. And so one of the things that we're going to do that I'm really excited about in this course is that at the end, when we talk about the operational characteristics, I'm going to give you a bright shining line of what constitutes a write scale system for which this would be unsuitable. And there are such, right? It's a tool. Like any tool, it's good for some things and not good for others. So we'll do that at the end. But just to introduce the idea, we believe that there are some small number of people who suffer from write scale problems, and everybody suffers from consistency problems. We're focusing on helping the people who want to have consistent systems and have manageable write loads. And we're capable of defining for you what a manageable write load looks like. All right. So for the first lab, we're going to go through the process of getting up and running, and we're going to go through several steps. We're going to install Datomic and start the transactor running. We are going to import the MusicBrainz data set. So we've taken, MusicBrainz is an open source data set of history of music and artists and labels and whatever. We've taken that and we've taken a small subset that's a good sample app that's got, I don't know, a few million facts in it. That runs from 1968 to 1973. We've empirically determined that that was the important period in music history. So hopefully as you're doing some of your sample queries, you'll be able to come up with something during that time range. Then we're going to explore Datomic using two different user interface tools, the Datomic console and the Datomic REST service. The Datomic console is an admin app, right? Something that you might use to connect to a system and futz around with it and look at it. And the REST service is a direct, raw REST exposition of all Datomic's capabilities. So it can do everything. Right? This is not something you would put out on the internet to manage your system because it can delete databases and whatever. It's a starting point for somebody who wants to export something via REST. Then we're going to get up and running in a closure REPL. This is optional. If anybody wants to do this stuff in Java, that's perfectly fine as well. And then work through the CRUD example. I'm going to do some of these steps super fast at the front of the room right now so you can see what I'm talking about. And then you guys can do them locally on your own boxes as well. So the first processes that you're going to run is the transactor. So this is you download Datomic and you get an unpacked directory. And there's a script bin transactor that launches the transactor. And the transactor you're going to launch with a configuration file. And that configuration file is going to specify which storage it uses. So is it storing to files on your local system? Is it storing to Postgres? Is it storing to wherever? It also has a bunch of operational settings that we are not going to touch in this class, and you typically don't touch very often in production either. And so I'll start Datomic, and it will tell me that it's launching, and hopefully after a couple of seconds, it's going to tell me that it started. In this case, I'm running in dev mode. So dev storage is for dev time. It's for development time. This is storage on the local file system on my laptop. The second thing I'm going to start is the console. So the console is the admin app. This is the console's included if you downloaded Datomic Pro. If you have Datomic Free, it's a separate download, but you can download it as an independent tool as well, and just drop it in the directory. Console, you'll notice, takes 4 arguments. It actually takes more than 4 arguments, but 4 arguments here. Dash P9000. Anybody want to guess what that means? Run on port 9000. Very good. The next argument, dev, that is an alias. That is the alias for a storage. So once you run the console, it's going to allow you, a single console could manage multiple Datomic instances. Right? It could connect to multiple different Datomic systems. And that's the name it's going to show up as in the UI in the console, and you'll see that in a minute. And then we're saying that dev is the name that points to this transactor on my local system, which is Datomic dev localhost 4334. 4334 is the port that Datomic takes for default, and that was what the transactor was running with. So the console is running against that, so I'll start that. And we will switch over and take a look at the console. So this is the console, and has a lot going on, but so you notice that I have dev storage here. So this is that storage alias I was talking about. If I was managing more than one system here, that drop-down would have more than one system that I could connect to. Then I'm going to select a database, and the database that I'm going to select is the MusicBrainz database. Then I can see the schema for the database, so I can see that the music database has releases, and the releases have a lot of facts about them, and tracks, and so on and so forth. And then over here, I have a couple of different tabs. The query tab will let me perform queries, so I will do find all the releases. So I'm going to say find all those entities that have a release. You're not supposed to know the query language yet. I'm just going through this really quickly so you can just sort of see. So this says find everything that has a release. And I'll run that query. And that query found 11,434 items. Right? So that's all the releases in the system. And I only returned the entity ID for those releases. So remember, all the facts in Datomic are entity, attribute, value, transaction. I can then click on one of these entities. I'll switch over to the entity view. And now I have a navigable view that says, well, this entity was performed by some artist. That artist was Liza Minnelli. It was released on some medium. That medium is format vinyl. That medium has other tracks on it. The track, The Look of Love, has an artist. Of course, now I'm going in circles, right? So this is me using the navigational capabilities, the graph-like capabilities of Datomic to say, given a thing, I can navigate to another thing, navigate to another thing, navigate to another thing. I can also, here from the console, work with the raw indexes. And this gives you a chance to expose yourself to the different data shapes. So I'm going to say, I want AEVT, attribute followed by entity, followed by value, followed by transaction. So I'm going to sort the database that way, and I'm going to say, give me all the values in the system for country name. And that gives me the raw data in the database. So you see when I ran that index, it says, give me the entire contents of that index. There are 257 country names in the system. And those 5 tuples that show up when you're in this index view, this is the raw stuff of Datomic. Right? That's literally what's in storage. It's literally what appears in your query results. The entity, the attribute, the value of the attribute, the transaction that put the attribute in, and time. Then the transactions tab will show you the history of the system. So you can say, let me just nav around here a little bit. And drill in and pick a transaction. And this is where it feels source control like. Like you have a user that calls up and says, I did something at this time and something weird happened. And you're like, okay, hold on a second. And you drill into that time and you say, well, there were 68 transactions there. And then this particular transaction added these 1,309 facts to the system. And remember that nothing ever gets deleted. So deleting is actually retraction. And what you'd see is a datum that was EAV added false. So I used to think that Stu liked pizza, added was true. I now think that Stu no longer likes pizza, added goes to false. And you can sit in this view and see how those things change over time. So that's the console. The other UI tool that we're going to look at, and you'll probably spend more time in the console, but if you're thinking about consuming Datomic from a non-JVM language, you'll be more interested in this. The REST API is another script, bin rest. Again, -p8080, you're never going to guess. It's running this REST service endpoint on 8080. And then it takes the same arguments that the console takes. Give me an alias for that Datomic system I want to talk to, and then the actual URL for that Datomic system. And the REST API achieves the REST objective of being self-documenting. So you can actually drill around in here and discover the entry points. Right? So it'll say, this will tell you, here's the URL you would use, and then it will show you a UI here, and then down below this bar, it will show you the data that would be returned if you were consuming it as a non-browser client. Right? So if you're consuming it as a non-browser client, it's going to come back in a data encoding form called Eden, the extensible data notation. And you can drill around here and say, OK, give me Music Brains. And notice that the URL appears updating every time. So that's the actual endpoint you'd go to get all the different things you could get. And then you could say, give me some datums. Give me AEVT for country name. And there's all the countries again. And there's the raw data. So if you were consuming Datomic, if you wanted to consume Datomic, the Datomic peer library as a service, the REST API is a starting point for thinking about doing that. Then the last thing you'll do in the lab so when you unzip the lab directory, you'll see that you have the slides in PDF, and you have the Music Brains backup. So you'll use this Music Brains backup, and the lab has instructions for installing from backup. You'll restore the Music Brains data into your own system on your own local box, so you can do the same queries that I was just doing. And then verify your ability to run and interact with data from the programming language environment of your choice. So the instructions here focus on using Clojure. So you would go into the Day of Datomic project, and you would run line REPL. So line is Clojure's build tool, and it's going to complain about stuff that doesn't matter. And then it's going to launch a REPL, and now I'm at a Clojure REPL, and I can start interacting with data like 1 + 1 is 2. But you're not going to see me working at this REPL because we have really good IDE support. So you'll see me working at this REPL instead. So this is running IntelliJ IDEA. You guys were all asked to install your own favorite IDE. So maybe some of you are using this one, maybe some of you are using others. But I will show you working at this REPL. So I'm going to, so the top is a Clojure program interacting with Datomic. The bottom is the results as I go and evaluate forms. So I will evaluate a form. I will then create a new database. So Datomic dev localhost 4334. And this database is going to be Day of Datomic, November 2014. So create the database. Create it. Oh, unsupported protocol. Let's use the free protocol. So I'm in a different system. There we go. I will then connect to the database. And I'll spell connect correctly with 2 N's. And then I'll put data in the database. So here is a transaction in Datomic. Add some new ID with the documentation string hello world. And we can jump back now, and we shall see that there is a new database, Day of Datomic, November 2014. We can go to the transaction index and see that there's one transaction, and that transaction added hello world. So I am going to, we'll take a bio break and then let you guys work through the lab. I'll be walking around the room helping people, anybody who needs help getting things up and running at any one of these steps. Thank you.